Good evening, this is Blake McHugh, and this is my first attempt for Chapter 5 video reassessment. Here you can see our problem. We have a wheel with a radius of 30 centimeters. It is rotating at 2 revolutions for every 0.08 seconds. Our first problem, A, through what angle in radians does the wheel rotate in 1 second? B, what is the linear speed of a point on the wheel's rim? C, what is the wheel's frequency of rotation? And D, what is the distance traveled in 150 rotations? So you can see, to start off with, draw a representation of our wheel. We know radius is 30 centimeters. We know our rate is 2 revolutions for every 0.08 seconds. Okay, A, through what angle in radians does the wheel rotate in 1 second? So basically what we're doing here is we're finding angular speed. And so we have to convert 2 revolutions per 0.08 seconds to x revolutions per 1 second. And you can see that's just a pretty simple conversion factor. You divide 2 by 0.08 and you get 25 revolutions per second. Okay, so that is our angular speed. From there, we know that angular speed is equal to our original 25 revolutions per second times 2 pi rads per second. Right here, our revolutions cancel, and we're left with 50 pi rads per second. And that is our angular speed. Okay, and then B, what is the linear speed of a point on the wheel's rim? Well, we're basically trying to find velocity. With velocity, we know that our angular speed times our revolution in meters will give us our velocity. So we have 50 pi seconds to the negative first, because that's since radians isn't a unit, a real unit. It's 50 pi over 1 second, and then times 0.3 meters, because we converted up here, we converted our 30 centimeters to meters, that's just moving the decimal place over twice, and we're left with 47.1, and that's going to be in meters per second. That's our velocity. Okay, and here we're trying to find our frequency. Well, I know that frequency is in hertz. 1 hertz is 1 second to the negative first. We got 25 revolutions per second. We got that back here, where we have 25 revolutions per second. And so that's the same thing as kind of taking out revolutions, and that gives us 25 seconds to the negative first, which is equal to 25 hertz. And the next part, this is just for fun. What is the distance traveled if the wheel rotates 150 times? Well, going back, we know our radius is 30 centimeters. We know our circumference formula is 2 times pi times radius, so we got 2 times pi times 0.3 meters. Again, we converted centimeters to meters, and that equals 1.8 meters per 1 revolution. And then we set that equal to x meters per 150 revolutions. We solve that and we get 282 meters if we rotate it, if the wheel is rotated 150 times.